Good afternoon, everyone, and I'd like to extend a very warm welcome to you to our webinar today, discussing our work with Microsoft to create a new data set that we've just released called Fields of the World. I'm Anna Woodley, Head of Sales and Marketing at Agrimetrics, and I'll be your chair for this session today. We're going to hear from Matthew Smith, Chief Product Officer at Agrimetrics, and also Barney Debenham, Industry Lead for Agriculture at Microsoft. Before we get started, I have some quick housekeeping to run through. Our webinar today will last half an hour. We do encourage you to submit questions via the Q&A panel, which you'll find on your screen, and we'll do questions at the end of the session. And we also will be recording the session, and slides will be made available to all registrants following the webinar today. As we go through the webinar, I'll start by telling you a little bit about Agrimetrics. Then Matthew is going to talk about why we created Fields of the World dataset. Then Barney's going to talk to us about Microsoft's AI for Earth programme. And then finally, we'll hear from Matthew again, and he's going to show us some of the content in the Fields of the World dataset and also how to access it. And then finally, as I say, we'll do some questions at the end. So for those who perhaps don't know so much about Agrimetrics, Agrimetrics is the food and farming sector's data marketplace. The company was founded to accelerate new value creation from agri-food data. And really what that means in practice is that we enable organisations to safely permission, share and/or monetize their data, whilst making it easier for data consumers to access the information that they need. Now, we do recognise that many organisations require help or certain expertise in making the best use of data. So we also do a lot of work on data enablement projects such as data classification, and we engage in collaborative projects such as Fields of the World, which we're showcasing today. And really our goal at Agrimetrics is to help create a more productive and sustainable food system by accelerating and enabling data-driven innovation. So talking about data-driven innovation, I'm going to hand over to Matthew Smith, who will introduce us to Fields of the World. Matthew, over to you.
Thanks very much, Anna, and thanks everyone for coming. Fields of the World is a new data set. It's one that we've created over the course of the past year, and we've just released it. Importantly, it's free to use right away for any use. We created Fields of the World to accelerate others innovate new solutions for agriculture. So it's all about innovating those new solutions. These new solutions are needed urgently to help us address the many challenges facing agriculture, and of course the opportunities for improving agriculture too. So some of them are summarised on the slide here, and overall they're about making improvements so that we can increase or maintain the quantity and quality of the food that we're producing, while minimising the inputs, while protecting and even regenerating the environment, and providing fairer rewards to farmers and others in the food system. So it's a huge set of challenges we're facing. And we're only going to address those challenges if we can make smarter decisions about how we're managing those agricultural systems and the agri-food system. And that's clearly where the data comes in. So you can see the logic in the diagram on the slide here, simplified logic. The data comes in as the key information about what's going on in our agricultural systems, and it enables those smarter decisions to be made and new value to be created. And typically making those smarter decisions requires that the relevant data is brought together and processed through decision support tools. And decision support tools are a mixture of algorithms, software, and other technologies that process the data. So it's that combination of challenges and opportunities to address them that's fueling this burgeoning agri-tech market. So what you see on the slide here are just some of the major commercial solution areas that are then emerging that involve combining data from different providers into decision support tools and decision support services. What's shown here are the major areas that agrimetrics work in and that require the use of data such as the Fields of the World data. I'm going to cover two specific example products from agrimetrics that will show the sorts of value you can get from the Fields of the World data. The first is the When to Go application we created with BASF, and that's used to advise farmers on when it's safe to spray herbicides. This was enabled by combining data on the status of the soil, the fields, and the weather, as well as a clever algorithm from BASF to then indicate to farmers when it's safe to spray chemicals so that, for example, it doesn't get into the waterways. And so that was built using data such as the data you get in Fields of the World. The second example relates to our Croplands AI algorithm. We at Agrimetrics developed this algorithm to enable the accurate identification of what crops are growing in fields long before harvest time. We built that to enable better foresight and accuracy into the quantities of crops being grown over large areas, so as to enable things like better price predictability for farmers and others in the agri-food system. And the tool itself works by using satellite-derived data linked to fields, pushed through an AI algorithm to tell you what the crop is. Again, this is just the kind of application Fields of the World could be used to innovate. However, building the applications requires the data to be found and brought together. And actually sourcing and connecting the data is loads of work. It's often said that the process of sourcing and cleaning the data takes much more time than it actually takes to do the analyses. And that's the key pain that agrimetrics addresses overall. What we do is make data from different providers interoperable and ready for analyses. Fields of the World was inspired and enabled by one of our other products, Field Explorer. Now, what I'm showing you here is actually a graphical front end to help people explore the data. Field Explorer is actually the system we run in the background to allow the data to be queried over the internet, and in this case, fed into this graphical application. With Field Explorer, we made it possible to obtain a wide range of useful location, weather, soil, and natural capital data from a range of different providers for each of the 2.7 million fields in the UK. And what I'm showing here is what can be explored in the tool. And you can see the range of data that can be selected on the left, and all that's been linked to fields. So you see some priority habitat information there, for example. That's the historical weather. You can see the historical weather there, the soil data, the topography data, and data about the wider environment. So Field Explorer was used to enable the development of When to Go and Croplands AI that I just showed you, and a range of other tools developed by ourselves and customers. So with Fields of the World, we've gone global with Field Explorer. We saw that up to now, there hasn't existed a global capability to provide data on fields from around the world. Of course, going global brings lots of advantages. For example, more people can get innovating on scenarios that are relevant to them. But also people can work out whether and how to make their tools more generally applicable to different or to more crops and to more in different countries. Now, it would be too ambitious to try to do Field Explorer for all fields on the planet right away. So instead, we wanted to start with a sample that we believe would be useful in the quantity and types of data that it has. And to be useful, a lot of modern methods need samples drawn from a population, which in the case of Fields of the World are multiple fields of the same crop from the same climate. And these populations of fields are needed to allow the modern statistical methods to detect useful patterns. And you couldn't do that with a single field. For example, when we trained that Croplands AI algorithm, it required satellite and ground truth data for many thousands of fields. So for Fields of the World, we settled on a plan to find fields from around the world for which we could get populations of a good sample size. Let's say 100 to 200 fields for the same crops growing in the same climate. Another challenge was to work out where do we get all the data from. over the years at Agrimetrics, we've actually seen a wide range of data from around the world that could be connected like we did with Field Explorer. And the problem was that these data sets were not being connected in a way that really was needed to enable the value to be created. And it was seeing that the data existed, but that linking didn't, that convinced us to pursue creating Fields of the World. So seeing that potential, we then reached out to our commercial partner, Microsoft, because we knew that their AI for Earth program supported the creation of data sets to accelerate the application of AI to solve environmental problems, including agriculture. And so we asked them if they'd be interested in partnering with us to create Fields of the World. To explain more, I'm going to ask Barney, Worldwide Industry Lead for Agriculture, to explain why Microsoft got involved. Over to you, Barney.
Thanks, Matthew. I'm Barney Debnam, Industry Lead for Agriculture at Microsoft. And over the past few years, since I joined Microsoft, we've increasingly heard from customers, partners, data scientists, developers, that they had a lack of gaining access to accessible data for learning and creation of AI-driven innovation in agriculture. And we saw this gap. We heard it a lot from our customers. So what we work towards is we have a program called AI for Earth. AI for Earth is a program that awards grants to projects that largely fall into 4 areas of focus. One around agriculture, one around water, one around biodiversity, and one around climate change. And we wanted to support these new applications of AI. So Fields of the World is a great example of how we are helping in companies like Agrimetrics that our grantees are providing data sets for agriculture. Fields of the World is just one of the outcomes that we'd like to encourage. So it's really a call out for those of you that might be interested in how AI for Earth could support your efforts. I'd encourage you to search for AI for Earth. We provided a link as well to gather more information, but go ahead, explore what grants we're seeking, apply for the grants, and perhaps use the good work and data set that Agrimetrics has put together here for Fields of the World to continue to push the industry forward. Finally, I'd like to thank Matthew and the entire Agrimetrics team for our continued partnership. Agrimetrics is a great example of how the Microsoft partner ecosystem has a positive impact on the industries we serve. Back to you, Matthew.
Thanks a lot, Barney. Brilliant. It's been great partnering with you over the years. So now you know why we've done Fields of the World. Let me give you more details on what it contains and how you get it. And to help me, I've accessed Fields of the World data myself, and I'm showing some of it in a Microsoft data visualization tool called PowerBI. The dashboard you see there is public, so you can interact with it yourself, and I'll explain to you in a second how you do that. So as you can see from the top right of the dashboard, we've got data on fields of 11 different crops in 12 different countries, totaling over 3,500 fields. And down on the left, you can see the different crops we have. So you see barley and bush bean and corn and a range of others. So that's the 11 different crops. And on the right, the graphs, you can see the breakdown of the quantities of fields we have. Now, if I click in the dashboard on France and hold down Control, click rice, I zoom in to the rice fields that are in France. And you can see marked here with the bright pink dots, those rice fields in France. And if I zoom in even more, you can see the individual fields. So this helps get across the clustered nature of the fields that I explained before. You can see that these different rice fields are in close proximity, even neighbouring in some cases. Now note, these points are superimposed onto a recent Microsoft Bing map. So this map image will have been taken from a different time than from when the records of rice were recorded. But this gives us a nice visual reference for where the fields are in the dashboard. You'll also see, if I zoom out in the dashboard, the that I cite a range of different data providers in the middle table here, and that's really important. So I've created this slide here specifically to highlight these providers. They're a mix of organizations from around the world who kindly provided us with ground truth information on what crops are growing in what locations. And we're extremely grateful to those organizations for making their data available for this purpose. The key thing we then did was to link these fields and their locations to a range of other useful data. So from the data providers, we've got the field locations. Those get recorded as the latitude and longitudes of the fields and the crop that was growing in that field and in what year. And to that, our data scientists added field boundaries, which define the spatial shape of the field and allows you to calculate field area, which is useful for computing field level statistics like overall yield, for example. And to that, we added data on soil texture in the field, indicating how much sand, clay and silt there is, which we got from the Global Soil Grids product. And this is useful in working out drainage and fertility properties of the soils, for example, for computing soil water balance and leaching potential. We also added weather data, of course, which we got from the European Centre for Medium Range Weather Forecasting. It gives us the daily temperature, rain, sunshine and wind speed data for the fields. And that, of course, is a key enabler for all forms of crop intelligence, enabling you to estimate crop properties, field water balance, detect weather risks and predict weather-induced risks like diseases, among loads of other things. Finally, we added properties derived directly from the outputs of European Space Agency satellites, the Sentinel-1 and Sentinel-2 satellites. These provide observations roughly every 6 days. Sentinel-2 returns optical imagery, and so from that we computed a commonly used indicator of crop development, NDVI, which I normally simply call greenness. And this is really useful in developing applications that require that indication of crop status and crop health. A disadvantage of the optical data is that it can be blocked by cloud cover, and so we only return data where there's no cloud in the image. The other data from ESA is Sentinel-1, and it doesn't have that problem of being blocked by cloud cover. That satellite sends and receives radar signals and they penetrate the clouds. And this is actually what agrimetrics use to classify the identity of crops using our Croplands AI algorithm. And so we've linked those reflectance measurements to fields of the world to support similar uses. Note too that the weather and the satellite data are continually updated, even today, providing real-time information about those properties in the fields. It was that which led us to say that we've got digital twins for those fields, because you can provide near real-time status updates without actually having to visit the field physically. So as you can see, it's a really impressive and useful combination of the data. It's also a lot of data. For any one field, we work out that you get around 10,000 raw data points. And the data are also quite varied structures. We've got spatial points and polygons, time series of different resolutions, categorical and continuous data, and then all the metadata as well that goes along with it. Now, this is typical of the kind of field data, and it makes handling it complicated. And that's why agrimetrics are made route to making that data available, is for it to be computationally queried over the internet, over something we call an API. And that means that the machine on the receiving end, which is programmed by the data scientist or a developer, can be set up to handle the data in the appropriate way, such as showing the field polygons on maps and showing time series of weather. But it's also why we don't just make all the data available as files. However, we have done that for one field, and I'll show you how you access that data and the fields of the world data more generally right away. So how do you get to the data? How do you get the data? Well, it's really easy. Step one to finding the data is to look at the entry for it in our data catalog. The data catalog is our public place where we enable data providers to advertise their data sets. So here's how you get to the data catalog. Go to our homepage, agrimetrics.co.uk. You scroll down and you scroll down to featured data sets. And you see there's the fields of the world entry and you click view in catalog. And then that takes you to this catalog entry, and in the overview tab of that catalog entry, you can see the high level details of the data set. You can see links to Microsoft's AI for Earth program. You can get that link to the PowerBI dashboard I was just showing. And you can get a link to an example of using the fields of the world data to drive a crop growth model, which I'll speak about in a minute. You can use the other tabs in the catalog entry to see more details about the data set and also see details about how you access the data and how you access those files I mentioned for that individual field. For developers looking to get started, as well as the Access Data tab in the catalog, we've got the developer portal, developer.agrimetrics.co.uk. From there, you can learn how to computationally query the data over the internet. We've also got our public code repository, where you can see walked through examples of using our tools and data, including the fields of the world data. So for developers, the code repository is where I'd probably recommend you start. If you go to the Fields of the World section, then you can walk through an example of using the Fields of the World data to drive a wheat crop growth model. And so what I'm showing on this slide here are some graphs from that walkthrough, because it helps to illustrate another use case for the Fields of the World data. That use case is driving that crop growth. It's using the data for crop growth modeling and crop growth forecasting. So on the left, you can see a prediction for a single field of the average development of leaves on a wheat crop for a model that's been driven by the Fields of the World data. And if you run that model for many fields, then we can start to produce average yield estimates, as shown on the right, for a sample of fields in different countries and in different years. So this is just the sort of analytics that can be used to provide insights such as what the harvest is going to be this year or what it will be, and how that might impact crop prices, or a smaller scale application such as informing crop management practices, such as working out how much irrigation is needed. So you can see you get a lot with the Fields of the World data set and the surrounding assets, as well as the key data, which you get for free. We've got the extensive explanations in the data catalog. You can play with the Power BI dashboard. You can see the crop modeling and code examples and download some sample data, all that for free. That's a load of resources to get you started. But I also want to remind you about why we want you to innovate with this data. Here again are some of the key innovation areas that we're seeing, for which Fields of the World can be a real enabler. Of course, developing these is about more than just the data. We know that well at Agrimetrics, not least because we're involved in developing such solutions with a range of customers and partners. So if you're interested in working with us to develop such solutions, please don't hesitate to reach out. Really keen to hear from you. So I hope that helps you see just how rich and useful the Fields of the World data is. I want to finish by thanking again all the generous data providers, of course, of Microsoft and the AI for Earth program for being a great partner for supporting Fields of the World. And of course, our amazing team of data scientists and software developers who did an absolutely brilliant job in creating the data set. And with that, I'll hand you back to Anna. Thank you.
Brilliant. Thank you, Matthew. That was great, and thank you, Barney. Right, we have a number of questions, so we'll jump straight into those. First question, Matthew, is probably one for you. It sounds as though it's a development question. Do you publish any data in Snowflake with the Snowflake data marketplace, or are we considering using it?
Oh, we are looking at Snowflake as a marketplace, but we are not publishing anything in there right now. But yes, we've been looking at that and been speaking to and working with Snowflake to explore how best to do that. Brilliant.
And I think just to follow on from that, we're always keen to work with any other data marketplace providers and other data systems. So if anyone, please feel free to reach out to us. Another question that we've got is, are the raw satellite data provided within the Fields of the World data itself, within the data set?
They're not right now. We might do that in future. Right now, we're making available the time series of the satellite properties, because typically what we find in applications is what people want to do with the raw satellite data is turn it into those time series. So we've taken away that heavy load and just provide the information that people want to compute from the satellite data in the first place.
Brilliant. Question for Barney. Barney, within Microsoft's AI for Earth program, are there any key initiatives or key focus areas that you're really keen to see people innovating in at the moment?
Yeah, AI for Earth is a part of a program, a broader program called AI for Good. It includes AI for health and some wellness. I mean, in some other philanthropic efforts. I'll speak about two. On the AI for Earth, we're quite interested in more scientific rigor around some of the soil carbon activities and regenerative ag activities. So that would be one area in AI for Earth. In the broader AI for Good, we are definitely looking for grants around smallholder disadvantaged growers around the world. So that would be another area where if you have good ideas about perhaps the intersection between ag tech and fintech and microfinance, another area to perhaps put in a grant.
Brilliant, thank you. A couple more questions, a few more questions actually. We'll see if we can get through them. Matthew, is there a method of bulk downloading the Fields of the World data for a local analysis?
The method, you can do a bulk download using the mechanism we set up that over API, and you can download as much in one go as you like. So you can download it all in one go, or you can download it in pieces. Typically, to my point in the presentation, if we just make it available as a large set of CSV files, you'll just end up having to redo what we've done with Fields of the World. And so the best way is to write that computational query to get all of that data down and use it for your purposes. And if you want any help in creating that query, don't hesitate to reach out to help@agrimetrics.co.uk.
A question's just come in from Adrian. Beyond agronomic data, are you working to collect data on inputs, impacts, or ecosystem services with a view towards Elm in the UK? And then he said, I understand this may be a plan for the future rather than something that's ready to go now. What's your thinking, Matthew?
We are doing that now for UK fields and wider, but particularly for UK fields right now as part of growing Field Explorer, linking in natural capital assets. We've just linked in UK fertilizer application data, and that's growing all the time. Indeed, to meet, particularly for the UK, then the growing needs to meet ELM's requirements. For Fields of the World, we haven't added that information yet, but that we'll consider that. And really, in terms of where we take Fields of the World, from this point, we really want to listen to what people think in terms of the directions they want us to take it.
Brilliant, thank you. I think we've got just enough time to squeeze in one last question. Yes, we have. So the final question, Matthew again, what would your favourite innovation to pursue be next at Agrimetrics? What's on your radar?
Yeah, that's a good question. I mean, on my immediate radar, and we thought about it with regards to Fields of the World, and it's just waiting there to be done, is crop classification. I mentioned multiple times in the presentation our Croplands AI algorithm, which then predicts crop identities for crops in the UK. And then we saw with Fields of the World, we've got the same data we use for Croplands AI, the SAR data, and additional data that could be used in such an algorithm. And it's for a wide range of other crops around the world. It's a brilliant starter data set for working out how you develop those crop classification models. It's a real opportunity waiting to be had.
Brilliant. Thank you. Thank you, Matthew. Thank you, Barney, very much. We are at time, so we're going to wrap up the session for today. all it leaves me with is to say thank you both very much. That was fantastic. I really enjoyed listening to it, and Barney, it's been a real great pleasure to work with Microsoft as well. So thank you both. If anyone has any other additional questions that they'd like answered, or they'd like some help exploring the system, as we said, please do reach out to us. We're really willing to work with people on this and help you access the data. So please reach out, and I wish you all a brilliant rest of the day, and thank you very much for attending.
Thank you. Thanks.
Thank you.